Same thing. Do the same exact thing, except I changed the sign to cosine. So we'll still do 4x plus pi. What would happen to this graph?
Well, it's going to go down.
Okay, it's going to start down. I like that, Kennedy. The only thing is sine and cosine. Would I still find the same 3 over there? Right here.
Yes.
Yes, I would. Everything stays the same over there. Would I still do all of the numbers, excluding the red graph? Would I still do all of the numbers that you see across? Everything stays the same there. There's only one difference. Okay? One difference. And this is the difference between 4.5a and 4.5b. This is it. You ready? Same thing, except where do I start? Where it crosses, I actually will start below because it's negative. If it was positive, I would start high. And Grant, this is why we were kind of talking about that. Now, at all the x's, what does it do? Where the sine hits the bottom, the cosine is going to go through. And where the sine hits the x-axis, the cosine will hit the top. Okay? So the yellow, I'm going to do the yellow. This is what the cosine graph would look like. So it would go here, touch. Cool. It's going to go up. Where's it going to hit the top, the highest point? 0. At 0, good. And I forgot to put 2 and -2. That's my bust. Right there. Where's it going to hit the x-axis again?
X.
X. You see this. See what's going on here. Where it hits the x-axis here, you're going to hit the bottom. Again, go through the x, hit the top here, come down, and hit the bottom. That right there is 2 periods. Okay? 2 periods. That's the only difference. Okay?
So that's why cosine you go through x.
Cosine goes through x's. That's it. So where I start, wherever my starting line is, sine goes through that. Cosine starts either at the bottom if it's negative or at the top if it's positive. Okay? And so that's why at every time, this is how I think of it, Grant, because you were asking earlier and I thought it was good. Every time at x's or dots, it's either going to hit the top or the bottom, or it's going to go through. If I remember that, it helps me to make it all even and be able to identify between sine and cosine. All right?
So that's why you do the x's.
That's why the x's are important. Yeah, so you kind of decipher. Otherwise, it can kind of get thrown off everywhere. Cool? Cool, cool. All right, do this for me. I want you to look on your stuff there. And I want to go over, I want to make sure I want to modify this because I said we wanted to do a homework one. Let's do level 2. Do you see level 2? I want to do y equals 3. Again, I told you we're going to try to get homework done. 3 cosine. Is it x plus pi there, Grant?
Yes.
X plus pi. I want you to do that one on level 2, just with someone next to you. Again, everything stays the same. So I still want you to go over and do these off to the side. The only difference is how we graph it. So I just want you to try it out. And then afterwards, we'll attack this one here. Okay? Cool? Yes, ma'am. What's up, Brett? Divided by 2. That would shift this to the left a little bit, right? Because that starting point would be negative 5. Now, if it was positive pi,
Yeah, like our range, your okay. It's option.
if it was pi, yeah, it was just how do I graph it from cool. So I'm gonna do that, do this, change your points to as if it was from negative pi, and now I'm adding 2 pi because that's my period, right? From negative pi, and see where your ending is, and then I'll come help you with the graph part.
Wait, what do you mean this is? It is.
So if I go from negative pi, right, from here,
Oh, where are we going?
I'm going to the right plus 2 pi, right? Does that make sense? So I'm going to have a middle and an end. So my ending is where I'm looking for. What would my ending be?
So I add 2 pi.
With negative pi, right? And what would you get there? Pi, good. Nicely done. So that would be my n. What would be my middle?
Yeah, but what are the numbers? 0.
Nice. Good. What would be my x's?
No, then you're 5. Then what is it? Your okay.
This one is a little tough. This one's a little easier to see because you got
Pi over 2.
nice. And would it be negative or positive on the first x? Negative. There you go. And then the other x would
Is
be
0 always in the
good. And just so you know that, I want to make sure you can see this. If I was not sure of this, if I take these two values and add them together, okay? So 0 plus pi is pi, and then I divide by 2. That's how I get to that.
What's the first step?
The phase shift. So the phase shift is our line of scrimmage, right? So what would be my phase, or my, phase shift? Positive or negative? I think it, because this is
negative.
positive, it's negative, right?
Yeah.
All right, that's the line of scrimmage. How far was our pass? How far did it go?
Pi. No, what?
I don't know. We're not asking you that.
On this one, right? It's 2 pi over b.
Wait, where do you start for the cosine? Do you start like right here?
Because b is 1, right?
Okay.
So if I travel 2 pi here, right? If I travel 2 pi from negative pi, where would I end up? So where would the ending be? Okay, so this is the tricky part, right? If I start at negative pi and I go a distance of 2 pi, what am I doing? I'm adding 2 pi to negative pi, right? So where would my end be?
Yeah, 5.
Positive pi. Good. Yeah. Does that make sense?
Yeah, because 2 pi is like in the middle.
Because 2 pi is what I traveled from negative pi. So if I took negative pi and added my period of 2 pi, I get positive pi. Yeah. So that would be where I end up. Cool. Cool. All right. Did someone have any questions at all? How are we doing? How did I get this?
Yeah.
The middle.
Not this. This was not here, right?
The numbers, the x's and
Yeah, the x's.
Did you get negative pi as my
Yeah.
phase shift? We're good there.
Yeah.
Did you get 2 pi as your period?
Yeah.
Okay. So you travel 2 pi from negative pi, right?
Yeah.
So if negative pi is my line of scrimmage and I travel 2 pi, 2 pi added to negative pi produces my endpoint of pi. Cool? So that's how I got to here on this one, right? So what's between negative pi and pi? 0. Good. So we would have 0 as my middle here.
And then you added 1/2 to get pi over 2.
Yes, so when I look at the middles between this, right, I notice between 0 and negative pi is
Negative pi over 2.
negative pi over 2, and between 0 and pi would be
Pi over 2.
positive pi over 2. Good. It's just the middle value between those two there. Okay? All right, so that's how I set that up. Is anyone confused on these 5? Some of you are continuing. Go ahead. Is there anyone confused on how I set that up? How are we feeling? Good? Okay, good. So what do I do at negative pi for cosine for this context of problem?
You gotta go up to the 3.
Nice, good, Kennedy. 3, negative 3 is down here, right? And I start, because it's cosine, I start where?
At the top.
At the top, good. And where do I go through?
X.
The x's, that's very, very key. Got me? Got to go through the x's. And where will I hit the bottom?
At the 0.
At the 0. Remember, at all of the points, each point, whether it's an x or a period, you're doing something there. Then I'm going to come back through the x, and I'm going to hit the top of my pi. Is that one period?
Yeah.
Yes, it is, because that could be repeated over and over again. Okay? Now we just continue again by going to an x period. Just make sure it's consistent. Okay? And we just need the period and the dot. So each time I go 4 across, what am I increasing by?
Pi over 2.
Say that again.
Pi over 2.
Correct. Every 2, right, Thomas? That's good. But every 4 would be what?
Pi.
1 over 4.
Pi. Good. Yeah, pi would be where we would be at, okay? All right? Kennedy, are you good on that?
Something like that.
I got you. It's tough. I'm telling you, this stuff is tough. Josh?
How come you only went 3 on lines over instead of 4?
I think I did 4, 4, 4. Did I do only 3 somewhere?
No, I didn't see it.
If you do, it will be just a little off, but if you label it, I'm good with that. Okay.
Can we do level 3?
And go from there. Yeah, we could do a level 3. We're kind of building up to it. Kennedy, I was going to ask you, just because I know you're not the only one, on that, does it make sense why every 4, based on my yellow points, okay? Every 4 would increase by pi for this problem?
Yeah, I wasn't paying attention.
Okay, gotcha.
Okay.
So 2 pi, 3 pi, and we're good.
Instead of looking at it, is there like a thing we could do add, like we did with the find the x's, like 0 plus x divided by 2? Is there a way you can find that for the other 2 pi and 3 pi?
Are you saying once I've gotten the yellows? Is that what you're saying? If you take the middle
Just to
point,
find the second, when you're doing the second period.
once I do this, if I've got the yellow values down here, I could take my first value and subtract from my second value, right? To figure out what it would be and just make sure it's positive because I'm going to the right. So negative pi minus 0 is negative pi. So in essence, what am I doing? I'm increasing by pi as I go across. It's one way of doing it. You could do it that way, for sure, for sure. So then you could just then say, okay, this is 2 pi, then 3 pi, and so on and so forth. Cool? All right, questions off that?
Does it end at the top right there? Or 3 pi?
Yes, it'll end just right here. If you kept going, that's okay. Like if you took it down here, Josh, and you went right here, I'm fine with that. You don't have to, you could keep going, okay? All right, one quick thing. All right, I'm trying to give you tidbits as we go, okay? The last new thing I say that, there's one kind of minor thing I want to hit on too. All of this stuff is just building, okay? And here's what I'll say. I'll do one more off the homework. I want to go over one more type of problem, one more type, and then afterwards we'll break it up. I've got a video we'll show. We'll need a breather after that, okay? So I kind of know that. So it's on the horizon, all right? So let's do this. Y equals 3 cosine of x plus pi. What if I took on the outside from this, way on the outside, I said plus 2. This is not A, this is not B, this is not C. It's just plus 2 on the outside, okay? Way on the outside. What would that do? Nice, yeah, and I think all 4 of you got that because it was like in harmony, okay? You would literally shift this up. So here's what I would do, okay? So not to confuse you, graph everything first like I just did. Change the amplitude, and what are you going to do with the amplitude? Move it 2 up. It's kind of like we call it D because it's A, B, C, and then D's on the outside. If it's plus 2 and it's way on the outside, then all of a sudden this ends up shifting up. So instead of redrawing it, I'm not expecting that. Change this to what? 5. Good. Change this to? -1. And we just shifted this up 2, and we're going to call it okay. All right? Sound good? That way you don't have to draw it, redraw it. Just do that at the very end if I included that plus 2 on the inside. Does that help you? Does that help? Okay? Cool. Say that again, Tom. Good question. We've already done the shift on the x through the phase shift. We just start wherever the phase shift is. Instead of starting at 0, it makes it much easier to start wherever your phase shift is. Great question.
Nothing outside.
Nothing outside.
Or amplitude be -5.
Say that again. I'm sorry,
I
Josh.
think the amplitude's -1.
Good question, because it was 3 and -3, right? And what I said is, what if I took this yellow graph and just suppose that I put plus 2 on the way outside? This shifts the graph up 2. So instead of trying to redraw it and try to mess with it, I just say that we're going to shift this up 2, and now 3 goes up to 5, and -3 goes up to -1. So really, where is 0? Well, if I was doing this, it would be not necessarily in the middle anymore. It's been shifted where? It's been shifted, I've got to think on this. It's been shifted up, right? Because it's been shifted up to. All right, but as long as you put these 2, I don't need you to tell me where 0's at. You just put them there, and I'm okay. All right? Cool? All right, can we do a level 3? This is the last regular one. I've got one quick thing, and then we'll take a breather, all right? Level 3. Oh, man. Did I give you those? Yeah. Jeez. What type of teacher am I? Seriously?
Is stuff like that going to be on the test?
Possibly. I'll try to throw one out there that could be that tricky, okay? That could be that tricky. But if we know our rules, show as much as you can, okay? So let's try it out. What is it again? Graham, you want to give it to me?
Y equals
2/3.
2/3 cosine x over 2 minus pi over 4.
X over 2 minus pi over 4. Really quick, what is A? 2 over 3. That makes no difference, right? Down 2 over 3. Good. And I put that over there for amplitude, 2/3. What is my B? Yeah, we don't use the x, but it's with x. So we just say it's 1/2, okay? So 2 pi over b, which is 2 pi over 1/2. Does that make sense?
Yes.
So you would flip that 1/2 to the top, right? Multiply. And then once we do, I got a lot of weird looks. Do I need to kind of look at that real quick? No, I saw a lot. I saw a lot of people, but then everyone's like, yeah. Okay, so if I did period of 2 pi over b, what is b again?
1/2.
1/2, okay, so we put it down yonder there. And we flip this to the top. Good. So it's as if we multiply 2 pi times 2 over 1, which would give me a period of 4 pi. That's pretty big, isn't it? But that's okay. We're still good there. So we know that our period is 4 pi. Okay. What's our phase shift? Pi over 4 over 1/2. Good. So it'd be pi over 4, which is our C, over our 1/2, which is our B. So here we go. Pi over 4 over 1/2, and what do we do now? Flip it to the top and go. Okay. I'm gonna give you a couple minutes to just try it. Okay, because I'm gonna go over it, but I want to give you a moment to try it. And again, we're coming up on a breather here. We need it because I know this is heavy. But I want you to try it out. Try this part out, and then one quick thing, we'll be good to go. Cool. Let's do it. Ty, have it come over here. You got it. How are we feeling? You good on this stuff? I just saw you. I used this illustration. Okay. I don't know why I was like, Ty, yeah. I was going to use Josh too. Just include you in there. How's it feeling? Is it?
I did 2 last night, so you were talking.
I love it. So you're done with this part, right?
Go so fast. Yeah.
Nice. Is there a back part to it too?
So there's one thing on the back part.
And then the next level ones? That might help you to do this. Take that -3 out. Grab that first. And then do the -3. That's the vertical shift or something. Something like that helps you. Same thing with -3 here. That would be a vertical shift because it's separate from the cosine. So if I take that out and grab this first, then I add the -3 to it, that might help you. Yes. So if it's separate, kind of away from the parentheses, away, we would say then that's just the vertical shift. Cool. Nice. Right on that, because pi over 2 is a phase shift that's going to be to my right. We know that that's the start, right? We travel at the distance of what?
I really don't know what I'm going to do.
So when I add 4 pi to pi over 2, you got 9 pi over 2. That's really good.
And in the middle.
They didn't do anything. They kept saying,
Once
you
you
have to
put
reschedule.
together, we find out.
Never happened.
Add 9 to a 9 for every 2. And yeah. Oh.
This doesn't give you more.
And then you just got to divide by.
That's so in Saturday school last year.
That's good. That's tough.
Oh, but you gotta have the same. That's 5 pi over 2. Oh.
Yeah.
So what's the apple?
I like that.
I like
I want to
that.
bring that up here, Grace. I never thought of it that way.
Yeah.
You can do that as well. Emma, do you know where you start when you're in down these
I don't.
Do you know how to get in the middle?
Exactly.
Mary Grace had a good idea.
You add multiple times.
whatever your period is, instead of adding that to my n, because this is halfway between a period, divide that by 2 and simply add whatever you want to divide by 2
Oh, yeah, you're right.
to my original to get what's here. It's actually easy. That's good. Hey, Mary Grace has got a good idea. I love it. I love it. Something different. I gotta get tickets. That was a good one. This is why we help each other out. That makes more sense. Yeah.
Wait, how'd you do your? I did.
How we doing over your team? Y'all doing okay?
So in order to get middle, what's wrong?
Before you do 1/2, you're right. Because we're averaging them together, correct? So when I add both of them together, pi over 2 plus 9 pi over 2, and then multiply by 1/2.
So 9. Oh wait, you can do pi over 2 plus 3 pi over 2.
And then multiply by 1/2.
10 pi. Would I use the reciprocal?
That makes sense?
Would I cross my?
I just multiply across. Good job. Did y'all get it? So did you start at, is it this one there? Is it negative or is it positive? I think it's positive because of this page. Does that make sense? Mary Grace, could I get you just to explain it? I'll be up here, okay? But I think that might help. Would you be cool with that? That was awesome. Okay, she did. She found a better way, and I love it. And sometimes, if you have a better way, share that. I kind of was coming around and snuck in, and I heard it, and I thought that was really good. Pi over 2. Now, when we do this, did everyone get pi over 2 as my starting line? Anybody not that needs some help on that? Cool. So we go again. Again, you could do my method in terms of going every 4, or if you have your own, that's fine too. Now, what's the distance on traveling? What was Ty's catch? What was the distance of Josh's throw? 4 pi, right? So if I'm adding 4 pi to my original pi over 2, what do I do with that in order to add them together? Common denominator. So I put a 2 on the bottom. What I do to the top, bottom, I do to the top, which would produce an ending point of 9 pi over 2. Good. Now, what I've said before is if you're confused on what the middle value is, simply add them together and divide by 2. You're really averaging them together, and that works. Okay? Mary Grace, I kind of snuck by, and I was like, oh, that makes sense, and this may make better sense to you, so I wanted to have her share it with us. Okay? So, Mary Grace, you want to just kind of talk through a little bit of what happened there? Y'all hear that? Take the period, 4 pi, divide that by 2 to get what?
2 pi.
2 pi, and add 2 pi to your original to get to the middle. I don't know if that blew my mind. That just blew my mind. Good. For a Buckeye especially. You know what I mean? Like, that was impressive. That was impressive. So pi over 2 plus 2 pi, what do I put on the bottom if I'm getting to the halfway point? 2, 4 on top, so what's the middle? 5 pi over 2. Do y'all like that better? Some of you may, some of you may not. That's fine. Okay? Okay?
What was another way of doing it?
Of my way or Mary Grace? My way, I just added these 2 and divided by 2.
And then you add those 2 divided by 2 to get the x.
Correct.
Okay.
With her method, she's saying, okay, instead of doing all that, just take the period, still get to the end by adding your period, right? You still want the end. But instead of adding by it and dividing by 2, just divide the period by 2 to get 2 pi and then just add it to my original. So if I did Mary Grace's method and got the quarter point, I would divide this by 4 to get pi, and every quarter point would be added by pi.
Yeah.
I kind of like that better, actually. Just me. But if you have that other way in your head, go ahead. So pi over 2 plus pi would be 3 pi over 2. Is that right? Yeah, 3 pi over 2. And then 7 pi over 2 over on that side. Cool? Am I going to graph up on top or am I going to go through? Let me say that again. Like with cosine and sine, we go top, right? Because it's cosine, we start at the top here. Good. What do we do with the x's? Oh, man. There we go. Say that again. What do we do? Where do we go through?
Well, I'm asking if it's actually 3 pi over 2.
Is it? How did you find that, Red?
I did his method where 7 multiplied pi over 2. You add pi over 2 and 5 pi over 2.
Okay.
Divide by half, or multiply by half.
Correct. So pi over 2 plus 5 pi over 2 is 6 pi over 2, right?
And then multiply by half.
Multiply by 1/2. That would be 6 pi over 4.
Oh, I see what I did.
See that there? Okay. Thomas.
Do we have to find the other x's or the other equals?
For the other one, no, you don't. Like as far as like when I graph this, right? And I come down here. Make sure you go through the x's. Hit the bottom, go through the x, and come at top, right? When I go back through and I do this, you do not have to find the other x's. Just the point. So then I would go, I think this is increasing by 2 pi each time, or 4 pi over 2 each time. So this would be 13 pi over 2, and 17 pi over 2. And then it would just come down, hit the bottom, and go like that. Okay? Cool. All right, hey, do this for me because I know we are about ready to be done. I got one quick thing, and then I'm done here in terms of for this part of the lesson. For the podcast, I want to just ask real quick because I know some of the football cheerleaders, bands will not be here, so I want to make sure I address this. Any questions on this specific problem or ones related to this? How do we feel? Okay? Okay, here's the thing. For the rest of class, after we do this initially, I'm going to provide kind of 2 avenues, and I'll explain that here in a second. But before I close the podcast, I wanted to give you one quick thing, okay? One quick thing. What if I changed, first off, what if I added plus 2 on the outside? What does that do again? Good, so my amplitude would go from 2/3 and negative 2/3, and it would just shift up 2, right? Okay, good. What if I changed, right here, what if I changed this cosine to a secant? So if it changed it to a sine, you would actually start here and just go through, right? We know the difference between cosine and sine. What would happen if I changed this cosine to a secant? Now, cosine and secant are what? Reciprocals, right? They're reciprocals of each other. So here's what we do. You ready? The only difference again, these are little things. We'll keep reminding you on this. After I graph it, literally everything in blue is what I would do. If it's a secant graph, I would do everything in blue. Nothing changes. Nothing. Except I add one more thing to it. Usually I do a different color because that's me. And then I know that cosine becomes secant by wherever it crosses the x-axis, I'm going to mark. Okay? Right where the x's are for the cosine, if it was sine, I would mark wherever it crosses the x-axis. And then what I'm going to do is I'm going to make a dotted line. Okay? Y'all remember this?
Asymptote.
Little asymptote. I love asymptotes. Okay? And then once I look at this, then how do I create a secant graph? Well, then I look in this vicinity here, and I notice wherever that point is at its minimum, I'm just going to create a parabola that falls in the asymptotes. Over here, what happens? Create a parabola that goes up in the asymptotes. You follow me? Down here, create one that falls inside of the asymptotes, and the same thing up here as well. Okay? That's the only difference. The only difference is you do what was in blue and just put what's in yellow added onto it. Go from cosine to secant, and then if I went from sine to cosecant, it'd be the same exact thing.